Hi, this is Mr. Zachary. This is question number 19. So we have a bow that's being shot, and it eventually hits an apple on a person's head that is zero point 0.2 meters above where the arrow started over here. So we're going to say, let's make height 0 at the level of A and B, because they're at the same level, and then C is 0.2 meters above that. So what types of energy would we have at point A, point B, and point C? Well, at point A, that's when the bow is pulled back. The arrow's not moving yet, so we have no kinetic. We've said it's at height 0, so that's 0. So we do have elastic potential energy, though, because the string is being pulled back. At point B, that's when the arrow is loose. Still at the same height, so 0 gravitational. It is moving now, and no elastic because the bow is not stretched anymore. And then finally, at point C, where it hits the apple, there is gravitational because it's above height 0. There is kinetic because it is moving, and there's no elastic because the bow is not stretched anymore. So the first question is, how fast is it moving as it comes out? So we can say the total at A is equal to the total at B. And of the types that it could have these different ones. I wrote in the gravitational for some reason, even though it's 0 up here. Crossed them out so that you can see. So we only have elastic potential energy at A equals the kinetic energy at B. Putting in the numbers that we know, we can find out that the, and I messed up here, so I had to correct it. We can find out that the velocity at B turns out to be 37.6 meters per second. Notice I made a couple errors because I had thought at B I was going to have a height to it, and I chose not to, and but 37.6 meters per second. Then the final question is how fast is it moving when it gets to point C? So we can say the total at A is equal to the total at C. If that's the case, these are the possible types it could have, but we already have determined which ones it does. So we can say that there's only elastic at point A, there's gravitational and kinetic at point C. Doing that, this again is just writing it out, putting in the numbers that we know, and then solving, and we get that the velocity at C is 37.5 meters per second. Very close to the velocity at B because it's not much of that energy is lost to gravitational potential energy, but a little bit, and so it's 37.5.